Hello everyone, this is Mrs. Fan and this is the recorded video for week 4 day 1. Just a reminder, for this week's schedule, we do have 2 minimum day. Both Wednesday and Friday will be the minimum day schedule. So please keep that in mind. And as for our topic, we are back to recording the lessons now that we finished our puberty talk. And again, for today's lesson, we are going to start with energy. So, what do you think energy is? What type of energy are there? As you watch the next video, I want you to think about what is one thing that you heard the video that you would like to share. Let's take a look at the video.
Yo, we don't get it when we rest, we get it from food. If you're a cow, when we eat you, we get it from you. Cows get it from eating the grass that they chew. Grass and plants get it from sun's rays, using photosynthesis, work even on Sundays. Light hits carbon dioxide in the plant, makes carbohydrates and some oxygen. You can't destroy it, but you can move it. You can't create it, but you can use it. You want your car to move, burn some fossil fuels, but just know that oil's something we cannot renew. But solar panels, windmills, hydroelectric dams all give us energy again and again. We can even get energy stored in the earth. It's geothermal heat from the core of the earth. It's the energy. This side of me, can you feel it? You feel it? It's the energy. It's letting us move whenever we step in the room. It's the energy. This side of me, can you feel it? You feel it? It's the energy. It's letting us move whenever we step in the room. You get it? Mechanical energy's all about that movement. So it's what happens when you're moving. Energy that's potential is stored, ready to get you like a bow and arrow. Pull back, a skiers when the snow's packed. They're at the top of the mountain. Look at them up there. I think I see some potential in them. Kinetic energies when they go. When the ball gets thrown or you run real quick to get home. Chemical energies from those chemical bonds in the food we consume and in the wood that we burn. There's chemical energy in the calories and tea from tea leaves soaking up solar energy. But hot tea has more energy than cold tea. Yep, you guessed it, heat's a form of energy. They call it thermal, like a thermal coat in the winter. What you need to keep your heat energy near you. Sound energies will make the speakers shake and vibrate. And Stevie Wonder thinks it's great. You want light energy, just set your microwave clock. It's the light waves that make your popcorn go. Electrons flow, that's electrical. They don't rest, flow through the wire like Kanye West. Nuclear energy's fission and fusion. Fission splitting atoms apart, fusion is fusing them. It's the energy. This side of me, can you feel it? You feel it? It's the energy. It's letting us move whenever we step in the room. It's the energy. This side of me, can you feel it? You feel it? It's the energy. It's letting us move whenever we step in the room. You get it?
What is one thing that you heard from the video? Go ahead and share it. You can write it down on a piece of paper, or I can share it with someone next to you. What is one thing that you heard from the video? Now with that, let's take a look at the definition for energy. So, as some of you have shared before, what is energy? Some people share that energy is the power to do work. Some people share that energy is what we need to charge our phone or your Chromebook. Now, the definition of energy, it is ability of a system to do work. But that definition is quite abstract. So let's take a look at more specifically to see different types of energy. For example, whenever a car moves or animal moving, that's mechanical energy. There is nuclear energy within the Earth core and also in sun and stars. When we're enjoying our breakfast and lunch, that is actually chemical energy. Electrical energy, that is again when we are charging our device, that's part of electrical energy. When you're using microwave to heat your food, that's actually a part of electromagnetic energy. And the one that we are going to focus on this few weeks will be thermal energy. So thermal energy is also known as heat energy. So here's a question for you. So let's say right here, we have a container right here, and we have 3 spoons. A metal spoon, a wooden spoon, and a plastic spoon. Again, a metal spoon, a wooden spoon, and a plastic spoon. If we put butter on top of each of the spoon, which spoon would you think the butter would melt the fastest in? Again, of the 3 spoons, the metal spoon, wooden spoon, and plastic spoon, if they butter on each of this and we put hot water on the bottom, which one do you think the butter would melt the fastest in? Go ahead and vote for which one you think would melt the fastest in. Would it be the wooden spoon, the metal spoon, or plastic spoon? Let's take a look and see what happened. Right here, you can see the container, and again, you can see the wooden spoon, metal spoon, and plastic spoon. There is butter on each one of this, and you can see that there is a bean on top of each of this spoon. So we can track where the butter goes. And again, right here, you can see hot water is being poured to this container. You can also see the steam coming up from the hot water. Now notice what happened, okay? Notice what happened right here. Notice there is the butter and the bean on top of each of the spoon. Whoa, do you see what happened right here? Do you see how it's sliding down? Wow! So it does melt faster in the metal spoon. If you click on the link in the description below, you can watch the full video as well. So this brings me to another questions for you. So we saw out of the 3 spoons that was given to us right here, we see that it melts faster in the metal spoon. But what if we have different types of metal? Right here on this gizmo exploration, you are given 4 different material: aluminum, copper, steel, and glass. Which one do you think he would travel the fastest? So earlier in the experiment, we see that metal spoon was able to melt the butter the fastest. In here, do you think aluminum, copper, steel, or glass would transfer the heat the fastest? Let me explain this lab a little bit more to you. So right here on this lab, we have beaker A on the left. Beaker A, it contains water that is 95 degrees Celsius. So it's really hot water. It's almost boiling water. And right here on beaker B, we have water that is 5 degrees Celsius. So this water is pretty cold. It's almost like the cold water you are taking out of the refrigerator. So we have, again, hot water on the left in beaker A and cold water on the right on beaker B. Each of these beaker is insulated beaker, meaning that heat is not going to escape outside. Connecting between beaker A and beaker B, there is a solid tube. Again, the water is not going anywhere. The water stays the same, but there is a solid tube made of different material in each set. There is one. This one is made of a solid aluminum tube, a copper tube, a steel tube, and also a glass tube. So which one do you think heat will transfer the fastest? If heat transfer, it will look something like this. You will see temperature dropping on one side and temperature rising on the other side. So again, which one do you think will transfer heat the fastest from the left beaker to the right beaker? Would it be aluminum, copper, steel, or glass? Take a moment and think which one you will vote for. Now at this time, you will have 10 minutes to explore this gizmo simulation. After you explore this gizmo simulation, go ahead and think about what is something that you observe. Okay, so in each one of this, again, click on aluminum, click play. What do you observe? Copper, click play. What do you observe? Steel, click play and see what do you observe. Glass, click play and see what you observe. Please pause the video at this time. Again, you can find the gizmo link in the description below. Alright, now that you have explored gizmo a little bit, what was something that you observed? What do you see? Let's take a look at each of this. Let's take a look at aluminum first. Again, on the left beaker, we are starting with 95 degrees Celsius for water and beaker B, 5 degrees Celsius. You could click play. Do you see how temperature go down right here? I want to make sure that the temperature is same for the left and right beaker. When they're the same, the heat transfer will stop. Right here, 50 degree, that is when they are the same. So for the aluminum, aluminum to transfer heat from beaker A to beaker B, it took 22.75 minutes, so almost 23 minutes. Let's do the same thing with copper. Okay, let's take a look. Whoa, do you see how the temperatures drop right here? Again, we're waiting for both beaker to have 50 degrees Celsius. Right now it's 50 degrees Celsius. For copper, to get to 50 degrees Celsius in both beaker, it only took 12 minutes. How about for steel? Let's take a look. Okay, we are seeing the temperature dropping in beaker A, and we are seeing temperature rising in beaker B. Let's take a look and observe. Here we can see that it's getting closer. But again, we are waiting for both sides to get to 50 degrees Celsius. Right now, this side is still slightly higher. We are 0.2 degree away. Another 0.1 degree. Alright, finally right now we are saying 50 degrees Celsius in both beaker A and beaker B, and it took 101 minutes for both beaker to have the same temperature. Let's take a look for glass. Notice how the temperature changed in beaker A and how the temperature changed in beaker B. Let's take a look. What do you see? What do you observe? All right. Well, for glass, it actually you can see that it doesn't change the way we see in earlier for aluminum, copper, and steel. Right now, after 70 or 80 minutes, this is still at 90 degrees Celsius, and on the right side is around 9 degrees Celsius still. And I ran this lab all the way to the end, and even to the end of the lab, the temperature was still very, very different. So my next question for you is this. Out of this four material, which one did heat travel the fastest? Take a look at the data and see which one did heat travel the fastest. And yes, you are correct. Copper is the one that traveled the fastest. Because in copper, it only took 12 minutes for the temperature in beaker A and beaker B to be the same. Next, we have aluminum, steel, and the slowest one would be glass. So let's take a look at the one from copper again. Now, as we take a look at what happened in copper, I want you to first focus on beaker A only. Okay, only focus on this side and see what happened. Do you see that? The temperature just dropped immediately. Okay, let's do the same thing, and this time I want you to focus on beaker B only and see what happened. Do you see how all of a sudden it just jumped up? Alright. This time I'm going to play one more time, and this time I want you to look at both of this together. Both beaker A and beaker B. As we look at this, the heat that is lost from beaker A is transferred to beaker B through this copper tube. Again, one thing that is very important to remember is this is not a hollow tube. This is a solid tube. The water is not mixed between the two beakers in any way. Water in beaker A remain in beaker A. Water in beaker B remain in beaker B. The only things that they have is that they have a tube that is in both beaker A and beaker B, and that is how the heat transfer. And this method of heat transfer is also known as conduction. And the material that allows energy to travel from one side to the other side is called conductor. So again, right here, conduction happens when you are directly touching an object. For example, I have my coffee cup right now. I am touching the cup and I can still feel the heat. Why is that? That is also known as conduction. Conduction happens when you're directly touching an object and feel the heat. When you are baking cookie, for example, and when you are taking the cookie out of the oven, you want to put on glove. Why? If not, it is going to be extremely hot. And what caused that heat? What caused your hand to feel hot? It is also conduction. Conduction again, it is when we are feeling the heat transfer because you're directly touching an object. With that said, today we will explore different types of energy in our Build 9 video. Make sure that you go to your Google Classroom, click on classwork, go down right here to week 4 energy, Build 9 video. On the left right here, you are going to see the Google document. Make sure to write down 10 notes. On the right, this is a Bill Nye video that you're going to watch. I'll also put the link of the Bill Nye video in the description below. With that, have a great day and I will see you next time.